Yes, thanks very much for having me here. I work for Specified Technologies, STI, and we are in the fire stopping business since 32 years, originally from the US. We basically focus on the compartmentalization part, basically the passive fire stopping. Why is this important to make this distinguishing? We don't have any products that are in the detection field or in the fire suppression field. Everything we do comes with the building, basically. Now, why is this important? Because the fire protection by compartmentalization is critical for every building. European buildings tend to be smaller in size than the comparable data center in the US. So you have more compartments. This is basically by building rules, and therefore we see more penetrations needed to get, for instance, the cables or services from one part of the building to the other. Now, what is happening, of course, it should not happen, but we all know during the operational phase of any building, changes take place, and these changes very often have a huge impact on the used fire stopping products in the building. Now, with piping, tubing, etc., not too many changes take place, and if they do, you rip out the whole building anyway. So then a new fire stop is inserted upon recommissioning. However, in case of cabling, nobody is really looking after the fire stopping unless you have an inspection program in place. Whereas I only know of a commissioning inspection that is mandatory for every building in Europe. But during the lifetime, it depends on the owner's needs for inspection or their own program to ensure that fire stopping is kept in place. And that is, of course, critical during the lifetime of a building, and especially as you see that the data and electrical cabling part is the one that is that sees the most changes during the lifetime or the operational time of a building. I think from the day of commissioning, the first thing that happens is that one of the electricians is called in to, okay, can you pull an additional couple of data cables because we need this desk to be moved from here to there, etc. Yeah, and if you then have to bring in all the time a specialist to rework the fire stopping, this is going to be a costly operation. I'll come to that in a bit. So, where are our products used? Yeah, basically everywhere. Where do we see most changes? In the data centers, in airports, quite important. High-rise buildings, not that much, unless they are leased to different companies or so, and they change the floors all the time. But in reality, it's not that often. Universities and schools, higher education, this is where a lot of computing is done by the students. By definitions, they like to play games. I got 2 at home, so I know all about it. And you see, of course, also a lot of changes there. Now, what do we have here in Europe as a standard the EN 13501, and below that are the testing standards EN 1366-3, and for the construction joints, so basically sealants and putties and acrylics that you put in the in between the concrete floor slab and the wall, or if you have a sandwich panel or a flexible wall, then you use a sealant to close those gaps. Now, this is all certified by a European technical assessment. So we have to run a test to get our sealants approved. You have to run a test to get any mechanical system approved. And for that, if you pass the test with either 90 minutes or 120 minutes, you are allowed to print a CE mark on your product, and you have a so-called ETA, European Technical Assessment, to prove that what you're selling also meets the standards. For what kind of walls and floors we are tested at the moment, it's the so-called flexible walls, or metal stud walls with gypsum boards on either side. Whether they're filled with rock wool or not depends a little bit on the country and also the purpose. We see, of course, rigid walls, so either concrete or masonry, and sandwich panels, and especially the last are replacing the flexible walls in data centers more and more. And the reason for that is because they're factory built, it's easier to deploy, and you just erect them on the site and you're done. On the flooring side, certainly in data centers, due to the weight that has to be carried on this floor, these are normally concrete floors of minimum 150 millimeters. In most data centers, it will be something like 250 to 300 mil, because of the cabinets and all the equipment that is being brought in there. But for instance, in airports, the flooring is relatively light. You see maybe 100 mil, or it's a combination of steel and concrete, just to create an even space you can walk on. Now, how do we cope with any penetrations there? You basically have the traditional methods, and I'm focusing here on the cabling part. You have the coated mineral boards or coated beds, where you do an installation once, and then if you have any changes, you just cut another hole and you ensure that somebody comes in, a specialist, to seal it off again. Foam is a little bit more difficult to handle because it hardens far more than the coated bed. It's not as easy to cut the foam out in the end. And you don't want to use a solvent, because solvent would probably also eat away the insulation on your cabling. A method that is seen a lot in the German-speaking countries are bricks. Basically intumescent blocks of material that they look like a stone. Yeah, so that's why they call it bricks, and put in there. There again, you can cut them relatively easily, but it's not so flexible as you would like it to be. And you need to be trained on repairing those, and doing the installation. Mortar, it's permanent installation. I recommend mortar for power lines or a larger cabling that is not changing. Anything there, I would say, you use mortar and you're good. Pillows, very flexible, so you can just remove them. What I've seen quite a lot is on installations that the pillows are being removed. They're being used for the electrician, especially when it's an underfloor system. They're used by the electrician pulling the cables to protect his knees, and then they're never put back again. And at the end you have just a big opening and nothing is in there. So the fire risk is quite prominent there. And of course, moving away from the more traditional methods to the mechanical systems, you have modular systems like those from Rockstack, which are great, but very expensive and very cumbersome to maintain. If you do need to change, you need to open it all up, pull them out, all the cables out, basically, and rebuild it completely. You have cable pathways and cable sleeves. The pathway that we're showing here is a very limited amount of intermittent, and the sleeve has the disadvantage that it doesn't equal the cable management. So you come from a square cable management and you enter a round device, which means that you have only limited amount of throughput there, and you would need far more floor or wall space to get all your cables through. So we developed for this the easy path as a high volume cable pathway that is in principle, as my American colleagues say, maintenance free, so you don't need to worry about anything really. When it's put in the wall from day one, it is certified that the cabling is or the barrier is restored to its original fire rating, and this is a device that's been on the market now for 20 years. It's especially designed for cable changes, and this is where it really comes to deploy in server rooms, in data centers, because that's where the majority of the changes take place. And as I'm the last speaker, I kept it very briefly. So I would say the key thing that I would like you to take away from this is look at the fire protection, the passive fire protection in your projects or in your building. Ensure that the cabling systems pass the barriers in such a way that you can easily do changes, that ensures your network integrity at the end of the day. And hopefully you will never need our product, because you don't have a fire. But any change will not cost you any additional money for the fire protection. Okay, thank you.